Okay, so now we're diving into chapter 17. This is the last in the level measurement section and talks about a lot of key characteristics of measuring level. And um, the first thing they hit on is bulk solids and silos. Obviously, if anybody's ever looked down inside of a silo, you know that the material that you drop down inside of a silo can be heaped up, and when you start emptying it out from the bottom of the silo, you get a big uneven surface. You might even get something called rat holing or bridging, and all these things can make your level measurements really, really hard and inaccurate. So as you do any of these measurement systems, you have to think about what the end effect is in terms of level. For instance, if you have a rat holing, where you put your sensor matters a lot. If I have a sensor in the direct middle of this silo looking down, it's going to look like that silo is empty. If I have a sensor here right on the left-hand side, then it's going to look like that silo is nearly full. The only way I can accurately understand how much quantity I have in that silo is by weighing the silo using my weight measurement system. So this chapter talks about kind of the pros and cons and the problems with level measurement in all different kind of systems. Dust is a big deal. It mentions dust. It can make measuring anything with laser or with ultrasonics more difficult. The book talks about something called load cell calibration, the procedure of figuring out how much your tank weighs empty, essentially, and then calibrating it as you fill it up. So there's a whole process to do that. You can read about that process. It's useful, but I'm not going to highlight anything. It talks about some common problems with water levels in a boiler and the challenges with measuring that. Mentions a few key terms in here. Water column, key term for boiler water levels. Fitting that reduces the turbulence of boiling water, provide an accurate water level. So it basically takes the hot water away from the rest of the boiling chamber and puts it into a column of water where you can measure the level accurately. Tricocks are basically spigots that you can open up to test to see if there's liquid at that level. Gauge glass, blowdowns, and basically these are all fun terms, and I'm going to highlight them because you should know what each one of these terms means and read about it. One of the other challenges we have with measuring tank levels is corrosive fluids or high pressure or dangerous fluids. Corrosion is actually a very, very big deal because it'll destroy any sensor that you put in there that isn't specifically designed for it. So we talk about different methods of dealing with that. And one way to deal with a corrosive liquid is you use something like a very high-tech corrosive resistant diaphragm seal. And they give you a couple possible applications for a diaphragm seal out application where you've got a point at the bottom of the tank where you would be measuring the pressure, and you compare that to a point at the top of the tank where you're measuring the differential pressure. That column difference is measured up, and you're protecting your measurement system. Your capillary and your high and low pressure measurement device is completely isolated from that dangerous sulfuric acid that they mention on page 175. So yeah, they're just a few little tidbits of data in chapter 17. Nothing earth-shattering, but useful little tidbits of data that will appear in the quiz.